Now we come to the really interesting part about effects coding, and in particular, this is unweighted effects coding. In order to illustrate and to be clear about how to compute these and how to interpret the B's, I'm going to start with a simple example. And believe it or not, the previous example was simple, but it was very complicated when it comes to interpreting things. So I'm going to start with a simple example where it's a large sample size because I want to have the easiest computations possible where we don't run into any problems with sample size or cell counts. I create two variables that are related to my y variable, my dependent or criterion variable, and I take these two variables and I cut them. I do a bivariate, a median split, and that median split produces roughly the same cell counts. It's not exact. It's about 250, 500, 750. That's just what happens. So what I have though is I have two predictors that are both effects coding. So you can see that there's -1 and 1 for E1 and for E2. Before it was complicated because we had 4 separate categories, and then when we included another variable there were 2 more categories, so it was just really complicated. This one, very simple. I have my effects coding specifically set up so that I can interpret them. And what I want to do is I want to show you what the means are. And these means are going to serve us well, because what we're going to do is we're going to step by step go through these coefficients. So I'll give you a summary of our model, and you can see these coefficients, -0.5, -0.7, -0.6, and 0.6, are the coefficients that we want to be able to replicate. And we want to be able to replicate them by simply computing differences between means or grand means. Now, as I've indicated before, at least in the last class, that for effects coding, the intercept is the grand mean. So if you take the mean of all of the means per group, so there are 4 cell means, if you take the grand mean, you will get the intercept. And you can see here, this is where I take the mean, and this is the output or the coefficient that I get from my linear model, and you can see that they're both the same. Second is I get my B1. So this is my effect for my main effect of E1. And this is the way I do it. I calculate it by taking the mean, and let me just show you what this is. So I'm taking the mean from the first and the third group, okay? And by taking the mean from the first and the third group, I'm getting the mean effect when the group is -1. Now I just need to show you. You'll see here, the reason for that is the 1 and -1 are actually contrast coded in exactly the opposite order. Okay, so even though this says -1, that is really 1. It's group 1. I know it's confusing, but I wanted to show you this, that these over here are just names. -1 and 1 outside of the matrix are just names. So anytime you see a -1, well, that was coded as a 1. Just like this would be dog and cat, well, dog would be 1, cat would be -1. So what I see here is I have to compute the mean for this guy here, which is this x is a mean. So the mean between this one and this one, and that's right here. That's the first mean, the first and third row of this little table, minus the mean of the second and fourth row. And when I calculate that mean difference and I divide it by 2, what I get is I get that mean effect. Because remember, when we're doing this effects coding, the effects coding is the effect between whatever category was coded as 1 and -1, and we have to take into consideration what that effect is when we take away the mean effect. And the mean effect is we have to take away the effect for E2. Okay? And that effect for E2 is in this second column here. Similarly, for B2, we're going to take the effect here. Remember that the contrasts are reversed as well. So we don't care what the labels are here. We care what the codes are in the matrix. And the code, we always want the ones, which is -1 here. We want the ones to be the first mean, and then we take away the -1s. Okay, so for our E2 effect, what it's going to be is we're going to have this mean and this mean, and it's the mean of these two values, subtract out the mean of these two values. Okay, and when we do that, we divide it by 2, and we get the coefficient for B2. Just to show you, this is exactly what we get. We get this coefficient is what we did by calculating from the means, and this is the coefficient from our linear model. This is calculated from the means, this is from our linear model. And then finally, the interaction is the tricky one. The tricky one because we have to think in terms of what would an interaction look like with respect to ones, right? So remember, interactions are going to be E1 times E2. So what are times in which we're going to get a positive 1 for that? Well, we're going to get -1 times -1 is going to be a positive 1. And we're going to get 1 times 1 is a positive 1. And we're going to contrast those multiplied values with the -1s. So with that logic, we would take the mean of this value and this value, and then subtract out the mean of these two. And then again, we calculate this by taking the mean differences, so this is the mean of means for these, and the mean of means for these, and divide by 2, and sure enough, when we get that, we get our interaction. So just to show you, we have indeed replicated all of these effects. We got a -0.54, round that, -0.7, a -0.68, and a 0.65 by using each one of these simple computations. I'm trying to make it easy for you because we only have, 2 means for each one of these groups. And that makes it much easier to compute. And so in class, what we're going to do is we're going to work on complicated examples that don't just have effects coding, but have a combination of effects coding and dummy coding. So stay tuned for that, because that's really, in class, you're going to learn a lot about how to interpret these effects, how to compute them, and then how to graph them. So stay tuned for the final video for this week, which is going to be a summary of all of the things that we've talked about so far.